It still works.
I got it. I got 9x over y to the second square root of y.
Yeah. I got that.
So remember, our first step is to just take the square root and put it on the top and on the bottom. That's the first step. Then from there, you've got to break up each square root individually. So on the top, I want to look at the number first. Can I take the square root of 9?
Oh, yeah, 3.
Yeah, it's 3. So on the top, I've got 3. Can I take the square root of x?
No.
No, there's not anything bigger than it. It's just x to the first.
So it just stay with?
So it's just x. Yeah, I can't pull anything out of that square root. So the top part's done.
Y2? Yeah.
So on the bottom, I'm going to have y to the second and the square root of y.
Wait, you don't put those together?
Because if I divide this y to the fifth, the 5 by 2, it goes in there twice with a remainder of 1, and the remainder is how many y's go on the inside. If I multiply anything by 1, does it change it? 1 times x is still x. 1 times anything is still whatever it was when I multiplied it by 1. So if I multiply this fraction by something on the top and on the bottom, it's not going to change the fraction because technically that's 1. So I need to multiply something on the top and bottom to get rid of the square root on the bottom. What is it going to be? It'll be the square root of y. Let's talk about why that is. Okay. Right now I have 1 y underneath the square root, right? And how many do you need before you can pull it out of a square root?
2.
You need 2. So I've only got 1 y, so I need another y underneath to be able to get rid of the square root on the bottom. But if I add a square root of y on the bottom, I have to add a square root of y on the top to keep the fraction balanced. Just like you do in an equation. Like what you do to the left side of the equation, you have to do the right, and vice versa. What I do to the bottom of a fraction, I have to also do the top. Because really, if I took this fraction, the square root of y over the square root of y, the square root of y over the square root of y, that's just 1, right? Because if I have the same thing on top and bottom of a fraction, they would cancel out and equal 1. So really, I'm multiplying this fraction by 1. So it's not changing the value of the fraction, but it's going to make it look a different way to get the square root off the bottom. Let's look at how we're going to simplify the top. I have 3. And since I'm multiplying 2 square roots together, I'm going to multiply what's underneath the square roots together and put it all under 1 square root. So it's going to be 3 square root of xy. I already have a y squared on the bottom, so when I multiply square root of y times square root of y, it's just going to leave me with 1y underneath. Because y times y would give me 1 pair of y's, so I'm going to pull 1y outside. Or y times y is y squared, and 2 divided by 2 is 1, so there'd be 1y there. However you want to look at that, it doesn't matter.
So the y's don't combine?
Well, they do. That's just what we're about to do next. So, what we need to do, on the top I really can't do anything. It's still 3 times the square root of xy. Then y squared times y is going to be what? Y to the third. So that's going to be my answer. So first step would be to separate the cube root on the top and on the bottom. Then the same as we did with the square root, we want to simplify the top and the bottom. So can I take the cube root of 8? What's the cube root of 8? It's what? It's 2. Because 2 to the third is 8. If I break down 8, I could break down 8 if I wanted to. Because I can break down 8 into 3 2's and have a set of 3 2's, so I can pull that out one time. So you can do that the same way we did it when we simplified fractions. Now with the power of x, the exponent of x, is 5. So I divide 5 by 3, and 3 goes into 5
2x.
one time. So it'll be x to the first, or you don't have to put the exponent there. Then what's going to be left under the cube root?
2.
X to the second.
X to the second. How can I break 64 down? Or does 64 have a cube root? Well, I could do 8 times 8. And then I could break each of those down into 3 2s. So I've got one set of 3 and one set of 3, right?
2 times 2 is 4.
It'd be 2 times 2 on the bottom, because I have 2 sets of 2, which is 4.
Whoa, how'd you raise that on the other?
I undid. Okay, hit undo.
Man, yours.
So since the power of y is 4, what I need to do, I need to divide 4 by 3. 4 divided by 3, 3 will go into 4 one time, which we don't need the exponent of 1, I was just writing it. Then we have a remainder of 1 left on the inside. So I'm going to have to multiply something on the top and the bottom. I just got to decide what that is. How many y's do I need to be able to pull out one y out of the cube root on the bottom?
3.
You need 3. How many do I have?
1.
1. So when I multiply, I need to multiply by what? Y to the second. On the top and the bottom. From here, what I have on the top, I've got 2x. When I multiply cube roots, it's the same thing as the square roots. I'm going to have x squared and y squared on the inside. Then on the bottom, I've got the 4y. Then if I were to just multiply the cube roots together, I would have y times y squared. From there, I can't simplify anything else on the top, because I've only got I've got x squared and y squared on the top, but I need 3 to be able to pull something out, so I can't do anything else with the top. Then on the bottom, I've got the 4 and the y. And then on this bottom over here, if I multiply y times y squared, I'm going to get what? Y to the third. And y to the cube root of y to the third is going to be what? Y. So I'm just going to have a y on the bottom. So I'm just rewriting the top. So on the bottom I have 4 times 4y times y, which is y squared. So my answer is that. Alright. Free response question, I would count this right because the AP test would count this right. But the 2 and the 4 on the top, we have to see if anything on the top and bottom will cancel out. I'm going to write it below here. So I have a 2 on the top of this fraction, and I have a 4 on the bottom here. Alright, so I can cancel out the 2. Alright, because on the top, 2 will go into 2 one time, 2 will go into 4 2 times. I don't have any more x's on the bottom. I don't have any y's on the bottom and the top, because since this y is inside this radical, I can't cancel those two things out. So your answer, you should also be aware that your answer could be x, because 1 times x is just x. So I could write the 1 in front, but I don't have to. I need to write another x. Cube root of x squared y squared over 2y squared. So you need to be able to simplify this. So we're going to split the fourth roots up on the top and the bottom. Then from there we need to see what we can simplify. Right, I can't break 7 down at all, so I can't simplify the 4th root of 7, so I just got to leave it as the 4th root of 7. Can I break anything down out of 3x on the bottom? No, I can't break anything down, but I've got to get rid of the square root on the bottom, correct? So I need to do something to the top and the bottom. Erasing all that? Okay, well, I'll put it back. Well, I can't do anything to simplify the bottom. So really it didn't do me any good to write that down. Alright, so I can't simplify anything on the top or the bottom. So what I need to do is multiply by something on the top and the bottom. So what can I... So, we know that I'm going to have to multiply by a 4th root on the top and a 4th root on the bottom. I've got to multiply by a 4th root on the top and the bottom. But I want my 4th root to make what I multiply by, I want it to make the bottom root radical disappear. So I need to figure out what do I need to multiply by to make this 4th root disappear. I have 1 3. How many 3's do I need to be able to pull one of them out?
4.
I need 4, so what am I going to multiply by here? You can make it an exponent, so it can be 3 to the what? 3rd. I've already got 1, so 3 to the 3rd is going to give me the 4 that I need to pull 1 3 out. Right, and I've got 1x, so my x needs to be to the 3rd as well. So, and then whatever I do to the bottom, I got to do the same thing to the top.
You just make
Like that.
7.
Because now, if I put these two things together, I've got 4 3's, so I can pull 1 3 out. I've got 4 x's, I can pull 1 x out. So I have 3x on the bottom. And it's always going to work out that way if you multiply the top and bottom by what you're supposed to. Then on the top, I'd have the 4th root of 7 times 3 to the 3rd, x to the 3rd. Which on a multiple choice test, they're probably going to want you to multiply that out. That doesn't really look like a 7. 7, 3 to the 3rd, x to the 3rd. So they're probably going to want, so that'd be 27 times 7. Alright, which is 189, I think. So we'd have the 4th root of 189 x to the 3rd over 3x.
Did you not pull stuff out of 189?
I thought you were asking if I.
So I want to multiply 1 plus the square root of 3 on the bottom and 1 plus the square root of 3 on the top.
I just said the conjugate on both top and bottom.
Right.
When the conjugate of 1 plus square root of 3 divides.
Okay, let me rephrase how I said that then. Okay. I want to multiply by the conjugate of the bottom. Whatever the bottom is, that's what I want to multiply by the conjugate on. On the bottom is going to be a problem that we're going to call... My teacher called it flow instead of FOIL. On the bottom. On this bottom part. No, we still got FOIL, but this is a different type of FOIL. It's missing some of the parts. We don't have to do all the parts when it looks like this. That's just what I do. It doesn't matter. I do the bottom first because it's easier. Alright, on the bottom I multiply by the conjugate, so I only have to multiply the front things together. 1 times 1. It's 1, then minus...
What am I doing? I don't know what I'm thinking right now.
Minus 2. Because root 2 times root 2 is 2. Alright, Then on the top, I have to do the full part, so that one's a little bit harder. So if it helps you, put them in parentheses so you can, if you have to see it like that to know that you're doing full, that's fine. I don't care. Some people, but that's what we're doing.
Why can't you just add those two?
So my first step is the two front numbers. So that's 3 root 2 times 1, which is just 3 root 2. If I can write. Alright. Then my next step, 3 root 2 times negative root 2. This one's a little trickier that I'd like to make. Alright, when I'm pulling these square roots out, alright, I'm always going to multiply what's inside the square roots. So multiply the two numbers. Are these square roots going to disappear? Because they're not exactly the same, right? So multiply whatever's in front of them together. 3 times 1 is 3, and it's going to be negative because the signs are different. Then, square root of 5 times the square root of 2 is going to be the square root of 10. Okay, now we just got to simplify this bottom part. Can I combine anything on this top? No, this is a 2, this is 5, this is 10. They won't combine anywhere. I don't have another number by itself anywhere, so I can't combine anything on the top. Then 1 minus 2 is what? Alright. So here's a good trick for a negative 1. If there's a negative 1 on the bottom of a fraction, and what's on top is something that's got 2 or more terms, so it's got more than 2 terms, go through and just change the sign of everything on the top. So this is a plus root 3 over 2, so make it negative, or square root of 3 root 2, sorry. It's negative 3 root 2, so it's going to be, and then plus 6, minus 3 root 5, then plus 3 root 10.
What does that do?